Hi there. In this video, I'm gonna show you how to solve the simultaneous equation by using matrices. So let's get started. Here is the example. So you just go to rewrite these as the matrices first and always end up equation like this. So in the first matrix we write the coefficient here, which is 4, 2, 5 and 3. So here is the coefficient 4, 2, 5 and 3. In this matrix we write the unknown variable, which is x and y, and then the right hand side goes there, which is 8 and 11. The reason these matrices, when you expand and multiply them, you just need to remember the multiplication matrices, which is row by column. So as you see that if you multiply first row with the first column, which is 4 times x plus 2 times y, is same as the left hand side. And if you name them a, x and p, that's x is equal to a inverse p. It's a simple way. You just use the inverse and the multiplication to solve the system of linear equation. So as same, if we leave the matrix x, y here, we get the inverse of the matrix 4, 2, 5, 3 times the matrix 8 and 11. So the inverse of any matrix is 1 time the determinant of the matrix times the adjunct of that matrix. So the determinant of this matrix is 1 time the determinant of matrix, which is 4 times 3 is 12, and the negative 5 times 2 is 10, times the adjunct of that matrix, which is 3 and 4. I just replace the value of this diagonal, and of the diagonal I just multiply them with the minus sign. So it's negative 5 and it's negative 2 times the matrix 8 and 11. I just simplify it in the next step. So 12 minus 10 is 1 over 2 times the multiplication of the matrix. So 3 times 8 is 24 plus negative 2 times 11, which is negative 22, and negative 5 times 8 is negative 40 plus 4 times 11, which is 44. So it's 1 over 2 times 24 negative 22, which is 2, and negative 40 plus 44, which is 4. So in the final step I just multiply 1 over 2 inside. So I get 1 and 2. So here is the answer. And we say that the value of x is 1 and the value of y is 2. So here is the another example. Just go ahead and find the solution first. So we just go to rewrite the matrices first, and we always end up the equation like this. So in the first matrix we write the coefficient, which is 5, negative 2, 7 and 6. In this matrix we write the unknown variable, which is x and y, and then the right hand side goes there, which is 16 and negative 4. If you name them a, x and b, you usually get ax is equal to b. That's x is equal to a inverse b. As same, if we leave the matrix x and y here, then we get the inverse of the matrix 5, negative 2, 7 and 6 times the matrix 16 and negative 4. So the inverse of this matrix is 1 time the determinant of matrix, which is 5 times 6 is 30, negative 7 times negative 2 is negative 14, times the adjunct of that matrix, which is 6, 5, and of the diagonal we multiply with the negative, so which is negative 7, and this one is positive 2. and the matrix 16 and negative 4. So in the next step, it's become 30 plus 14, which is 44, and the multiply of the two matrices by row and column. So 16 times 16, which is 96, plus 2 times negative 4, which is negative 8, and the negative 7 times 16, which is negative 112, plus 5 times negative 4, which is negative 20. So in the next step we just simplify it. So it's 1 times 44 and 96 negative 8, which is 88, and the negative 112 and negative 20, which is negative 132. So in the final step, I just multiply 1 over 44 inside the matrix. So 88 divided by 44, it's become 2, and the negative 132 divided by 44, which is negative 3. So we get the value of x and y. So the value of x is 2 and the value of y is negative 3. That's the answer. So that's the end of my video. If you wanna see more video, please feel free to subscribe my channel, and if you have some question, please leave your question in the comment box. See you in the next video.